Alright guys, so let's go a little bit quicker. It says, which of the following is necessary to calculate sensitivity of this test? Now, whenever I see the word sensitivity or specificity or positive value, we're always going to draw the box, okay? And I'll just put reality and the test, positive, negative. A new blood test to detect prostate cancer is evaluated in 300 males. A needle biopsy of the prostate gland is done on all men with serum prostate-specific antigen concentrations greater than 5. So a test is done if it's more than 5. 100 men undergo the biopsy. So we're just going to put that there. Of these 300, 100 men undergo the biopsy. That means 200 did not. 90 of those are found to have prostate cancer. So let's just put cancer here, okay? And so how many people of those had cancer of those? They said 90, right? 90 of the 100 had the positive cancer. And 5 are found to have chronic prostatitis. Which of the following is necessary to calculate the sensitivity? Now we know sensitivity is top left going down, so one of these answer choices has to describe that box, right? Because sensitivity is 90 over 90 plus whatever that number is. Okay, we can just call it X for now. Is it A, the incidence of chronic prostatitis in the general population? Does that describe what this box is? It does not, so it's not going to be that. Is it B, the number of men with test results greater than 5 on a normal biopsy specimen? No, because remember, if it was greater than 5, then that would have been a positive test, right? So is it C, prevalence of the chronic prostatitis in the general population? No, that does not describe this box. Is it D, prostate biopsies of men with test results equal or less than 5, right? Yeah, because this is the group that underwent the test. If it was greater than 5, you fell into this test. If it was less than 5, you fell into this box. And this is the box that we needed to figure out sensitivity. So it's going to be answer choice D. Now again, you see what they did here is they needed you to say that you need to find this box versus any of these other guys, and this box was described in words, and all the step exams are real popular in wanting to do that. So know how to work this type of problem. This one says, which of the following best represents the absolute risk reduction for vomiting among patients in the azithromycin group? So absolute risk reduction, we got to know our basic formulas, is event rate control minus the event rate placebo or treatment. It's always the absolute value, so really I don't care which one comes first. A randomized controls trial is conducted to assess the risk for development of gastrointestinal adverse effects using azithromycin compared to erythromycin in the treatment of pertussis in children. Of the 100 children with pertussis enrolled, 50 received azithromycin and 50 received erythromycin. So let me see, we're going to say 50. And this is, I don't even know if I really have to write this down, but 50 and 50. Results show vomiting among 5 patients in the azithromycin group. Okay, 5 patients had nausea, vomiting, and then compared to 15 patients in the erythro group. So which of the following best represents the absolute risk reduction? Now, since there's only 2 of these, it doesn't matter which one you're going to call the treatment versus placebo. We just got to take the difference between the 2. Now the event rate of, let's just put the erythro first, since it's a bigger number, it's going to make our lives a little easier. It's going to be 15 out of 50, okay? Minus the other treatment, or the placebo, could be azithromycin, which was going to be the event rate was 5 people had the nausea out of the 50, okay? And so when we subtract these, it's basic math here, and we got 10 out of 50, right? And now this goes back to your high school algebra. You got to have a common denominator and all that kind of good stuff. And so you're going to get 10 out of 50 or 0.2, okay? That's how you solve that one. So that would be answer choice B as in boy, okay? But you had to know the formula, okay? Absolute risk reduction, event rate control minus event rate placebo, all under the absolute value flag. Okay, this one says, which of the following is the most appropriate conclusion about the effect of regular exercise on the risk of hip fracture? So we look up here, we look at our answer choices. They're talking about statistically significant or increased risk. So in a cohort study of elderly women, the relative risk ratio for hip fractures among those who exercise is 1.2. Okay, so relative risk is a 1.2. Now that's greater than 1, so that means there is some type of risk there. And so it's risk for people who exercise. So what it's saying is, if you exercise, you would have a 1.2 times greater chance to fracture your hip. But we have to always look at this. What is the confidence interval? What do we not want that confidence interval to contain? We don't want it to contain 1.0, because if that confidence interval ever contains 0, like 1.0, so if it was like 0.8 to 1.2, we don't like that, right? Because somewhere in there, there was no difference between whether someone exercised or not. But what this is saying is that when data came back, you were either at a 1.1 to 1.8 times higher chance of having a hip fracture if you exercised. 95% confidence interval. So what does that data mean? What does this 1.2 mean? Statistically not significant? No, because it is significant, right? We had a good confidence, 95%, and this endorsed it that it was actually good. So anything that has not significant is going to go away. So is it statistically significant overall decreased risk or statistically significant overall increased risk? Well, the fact is it's greater than 1, so it's going to be an increased risk. Now, if all these numbers were a little bit different, say this thing was like 0.8, okay, say it was 0.8 and then the confidence interval was 0.6 to 0.9, then you could have said if you exercise, there's a 0.8 or less risk than doing nothing to fracture your hip. In that case, it would have been a decrease. But the fact is, this one was 1.2, and it's a 1.2 means it's greater than. So you're going to go with the answer choice D, as in dog. Okay? Now, when you get something like this, you better put a big smile on your face and know we're going to get these right, all right? I don't even read this garbage up top. I go straight to the box. Specificity, okay? Bottom right going up. Whatever we circle goes on top. Whatever line we draw between the boxes goes on bottom. 95 plus 5. So it's 95 over 100. And that's going to give you 95%, answer choice E. Remember, go back and review that first video. Sensitivity, specificity, positive predictive value, negative predictive value. This is almost guaranteed it's going to be on the step exams, and we got to nail this, got to get it right. This one says, 5-year-old, well actually read the question. Which of the following is the most appropriate interpretation of these study results? Okay, whenever I see this, I always start, first of all, I scan to see if there's a confidence interval in here. I don't see one offhand in this, but what I do see is a p-value, and I say, well, okay, well, p-values looks pretty good, right? Because we care about the p-value being 0.05 or less, because that means there's a chance, it's the chance of something occurring by, quote, chance. So we want that to be a small number. So it says a 5-year-old boy is brought to the physician by his mother because of a 2-day history of low-grade fever, cough, and runny nose. His temperature is 104. Examination findings are consistent with diagnosis of a common cold. The physician refers to a randomized, double-blind, placebo-controlled trial that evaluated the effectiveness of a new drug for the treatment of the cold. The mean time for the resolution of symptoms for the patient receiving the drug was 6.4 days. So if you received the drug, your symptoms lasted for 6.4 days, compared to the mean time 6.7 if you took a sugar pill. So there wasn't much difference, 6.4 versus 6.7, not too much, even though it had a good p-value. So what are my answer choices? The findings are clinically and statistically significant. I like statistically, but I mean clinically, 6.4 versus 6.7 is not too impressive. The findings are clinically insignificant, but statistically significant. Okay, I do like that one. The findings are clinically significant, but statistically insignificant. No, because this is statistically, it was good. Okay, so it can't be that one. The findings are neither clinically nor, no. Okay, so the only answer choice that matches this data, statistically significant, but clinically insignificant. When we look at that, answer choice B as in boy. Okay. Now, this one says, It starts talking about this type 2 error and all this. So anytime I see this, I automatically start thinking about the null hypothesis and our box stuff. And remember, on your exam, you're going to get a little scrap sheet of paper, essentially, where you can, it's like laminated, and you got markers and stuff like that. And I always just kind of drew stuff on it just to get me a reminder. I always do this, alpha, beta, 1 minus beta. It's also known as the power, right? So anyways, it says if the study has been performed in a population of only 500 patients, which of the following would have been most likely to increase? Okay, well, let's see what they're asking. A study is conducted to assess the effectiveness of a new drug for the treatment of type 2 diabetes. A total of 1,000 patients, okay, with type 2 diabetes are enrolled. Patients are randomly assigned to receive the new drug or standard treatment. The alpha and beta values for calculating probability are 0.05 and 0.2 respectively. Now you had to know alpha and beta, right? Alpha is going to be right here, also known as the type 1 error. So we're going to put 0.05 there. It's like p-value, right? And then beta, also known as a type 2 error, and that's just flat out for memorization. Got to watch those other videos. Goes right there. So without even looking at this, what is the power, right? It's 1 minus beta, so it's 1 minus 0.2, 0.8. So I got everything in the box. So results show that the new drug is significantly better than standard treatment. If this study has been performed in a population of only 500 patients, which of the following would have been most likely to increase? Okay, so what they're saying is they're going to try to reduce, they're going to reduce the, what are they doing? If they're taking it down like this, they're going to reduce the power, right? When your number goes down, power, when the n goes down, the power also goes down, okay? Right? Because that's what they always said. How do you make power go up? You increase the number. But in this situation, they're going from 1,000 down to 500. So power is going to decrease. So what would happen to alpha in this situation? Probably alpha is going to, alpha would probably go up, but that's not one of our answer choices. Would it increase the chance of a type 1 error? No, actually, if we did that, if we increased alpha, that would actually decrease our chance of making a mistake, right? Because it would give us more leeway. So that would actually go down, so it's not going to be that choice. Chance of a type 2 error. Well, let's think about this. We said if the n goes down, the power goes down, and if this goes down, if it went to 0.7 or 0.6, that means this guy's got to go higher. So the chances of making a type 2 error went up. So I really like that one. And we know the power of the study isn't likely to increase. The power actually went down, and then sensitivity specificity had nothing to do with this box, so I'm eliminating those. So the only answer that's going to work on this one is going to be answer choice B as in boy. But you see what they did? They decreased the power. And if you know that these things just add up to 1 and I decrease the power, then this guy, beta, or the chance of a type 2 error is going to go up. Answer choice B. All right. This one says, which of the following is the relative risk? Good, all right? We like relative risk. Death from this type of cancer in individuals who take drug X compared to the individuals who do not take drug X. All right, good. So it says a physician is conducting a retrospective review of a trial involving the use of drug X in patients with a specific disease. It is known that drug X is associated with increased probability of cancer in patients who use the drug. Okay, blah, 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 blah. A total of 600 individuals, okay, with a specific disease were included in the trial. So I automatically know if I'm dealing with this stuff, I know at some point I got to draw a box on this. And you can draw the box however, go with the words, but remember, it's whatever's mentioned first is what you write first. Now, I know that doesn't mean much to you if you haven't seen that first video, but let's just work it out. So we know we are going to label our box reality, and over here is actually the test, positive, negative, positive, negative. It says there's 600 individuals who have this disease, okay, who are part of this. We're including the trial. Of the participants, 200 received drug X. So So let's just put that one up here. Let's just put drug X up on our reality thing, okay? 200 of those N received the drug, okay? So that must mean that 400 did not, okay? I can buy that. And 400 did not. Good. 100 individuals who received the drug died. So let's just put died over here. Okay. So died here, and so of the 200 who received the drug, 100 of those individuals passed. All right, that's fair. And 100 individuals who did not receive the drug died of the same type of cancer. All right, so they're saying that of those 100 who did not receive the drug, who did receive the drug, didn't die. Okay, so based on this data, which of these is the following risk of death? Okay, well, I'm kind of missing something here, right? Wait, they did die. 100 individuals who received drug X died. All right, so 100 who received the drug died. Got it. And 100 individuals who did not receive this drug died. Okay, wait. So this was actually in the wrong box, because the 100 individuals who did receive the drug, who did not receive the drug, died. So this is the die category. And these guys did not receive the drug, these 400. So it's 100 of those guys died. Okay. Ironically, I still get 100 in this box because there was 200 people who received the drug. 100 of them died, 100 of them didn't. 400 people who did not receive the drug, out of those, 100 people died. So by default, how many people are in this box? 300, okay? I almost made an error there with my explanation, but I'm going to slow it down for a second to make sure we're clear. There's 600 people in this study, okay? And then of those participants, 200 received the drug. That means 400 did not receive it. 100 of the people who received the drug died, okay? And 100 individuals who did not receive the drug died. Now, based on the data, which of the following is the relative risk of death? Okay, death, right here, okay? These people died from this type of cancer in individuals who take the drug compared to people who did not take the drug. Now, when I do relative risk, I have to say, so it's the people who, and this is important because how did this read? Relative risk, people of death from this type of cancer who took the drug compared to people who did not. People who took it versus people who did not take. Now, if you remember correctly, we said that a case control had all that stuff is one number is associated with the odds ratio, and that's one number over one number, but a relative risk is one number over two. So the people who took the drug is 100, right? 100 over two numbers. That's 100 plus 100. Over the people who did not take the drug. That's 100 over 100 plus 300. Now again, I explained that in that first video, but you got to have this down, okay? Because they're talking about relative risk here. And you got to go, it's one number over two. If they said odds ratio, you'd put one number over one number, okay? And if that's a foreign language to you, watch that first video. So when we solve this, we got 100 over 200 divided by 100 over 400. Now, if you do all your simple math, all your basic stuff, 400 over 100, okay, all these guys cancel out, and I'm left with 400 over 200, or I'm left with 2. So my relative risk of people who took it, of the people who take drug X compared to people who did not, of dying, is a relative risk of 2. So, is it A, individuals who take the drug X have an equal risk of dying? Nope, because if that was the case, it would have been 1. Individuals who take drug X have 4 times the risk of dying? Nope, it's not 4, it should be 2. Individuals who take the drug X have 3 times? Nope. Individuals who take the drug have 2 times risk of dying, right there, okay? The risk of dying, yeah, it can be determined. Very important problem, guys. They could have said they said relative risk, they could have said odds ratio, it doesn't matter. You got to be able to draw this box. I could have labeled this thing opposite. It doesn't matter, because if you know if you know how you can just, whatever goes on top is whatever you said first. The people who took the drug went on top over the people who did not take the drug. Okay? It seemed like a long problem, but at the end of the day, this is one you can guarantee to get right on your exam. All right, this says, when otherwise covariates are controlled, covariates, I'm sorry, which of the following is the most appropriate conclusion? Okay, and talks about all this risk. Okay, let's just read it. Because it's talking about, here's some odds ratio stuff and confidence interval. Now, when I see confidence interval, what do I scan for? I scan for something that's garbage because it crosses 1. Okay, so I don't like to use that data. I'm going to use that same strategy when it comes to drug ads. It says, a case control study is conducted to assess the risk factors predicting inpatient mortality among geriatric patients with community-acquired pneumonia. Results of the study include the odds ratio shown below. Okay, remember odds ratio? It's almost like saying there's a greater risk, right? It's a 3.3, 2.4, and 1.3, which are calculated from a multivariable logistic regression equation. Okay, too much information. So, when all these are controlled, which of the following is the most appropriate conclusion regarding these data? Is it the risk of inpatient mortality is greater for patients with hypotension than for those without? Okay, so it looks like, so if it looks like the risk of hypotension is 3 compared to that, so I mean that one actually without hypotension, that looks pretty decent, so I'm just going to put a question mark by that one. I hate to jump on that and just move on to the next one. The risk of inpatient mortality is increased by hypoxemia, by more by hypoxemia than by hypotension? No, because hypoxemia is only 2.43 greater risk, whereas the hypotension is it's a 3.3 times greater, so it's definitely not that one. The risk of inpatient mortality is increased when there's a pulmonary infiltrate. Now look, how come I don't like that? I don't even want to look at that, okay? Because why? The data is garbage because the confidence interval crossed 1. Because at some point during that study, it actually was a 1-to-1 ratio, meaning it didn't have a difference. So I don't like to use anything that has a confidence interval. I don't like to use any of that information that has a confidence interval that crosses 1. So automatically off the table for me. The risk of inpatient mortality is significantly affected by all of them. No, I can't say that because again, I can't use this guy because of this right here, crosses 1, so I agree with that. So the correct answer is going to be answer choice A. The risk for inpatient mortality is greater for patients with hypotension than for those without hypotension. Okay, 3.3. Okay, answer choice A. This one, all right, kind of a two-bagger here. Go straight to the questions. Which of the following is the most accurate interpretation of these data taking Saul Palmetto? So again, you got to interpret this chart. A lot of times you can just answer the questions just by looking at this, because that's a pretty big paragraph to read. So when I look at this, it says patient reported versus physician reported. There's a placebo data between the two, and the treatment was the Saul Palmetto between the two. The statistical significance actually looks pretty good, right? Because the p-value is very low. We like that. So which of the following is the most accurate interpretation of the data? So at this point, I don't think I need to read this. I like looking at the charts. Improvement is seen in both physician assessed and patient reported. Well, it looks like placebo versus treatment went from 58 to 74% in patient and 38 to 73 in physician. Okay, so that's decent, but I don't want to get scared off on this yet. Patient reported symptoms are more improved than physician. So are they saying that the patient improved more than the physician? Well, the numbers are a little higher, but what was the actual difference? You know, if I did 74 minus 58, 6.1, so there was a 16% change in the patient one, and then the physician one went from, difference is 63 to 38 is 25. So actually there was a bigger change in the physician one than the patient one. So we definitely know it's not that one. It's kind of backwards. Statistical significance is not important compared with symptom improvement. I don't know. That's kind of that's a bit much, and I don't know if we can actually prove that on that one. Statistically significant changes in the physician-assessed symptoms do not result in decreased symptoms. We can't make that statement there. That's too much of a kind of a gosh, there's a fancy term for it, but we can't pull that statement from that data because statistical changes in efficiency do not result. Well, yeah, we don't know this as far as the significance. We have to compare those numbers. No conclusion can be drawn from the present information. No, we can't really say that because I think we can actually, this first one looks actually pretty good. Improvement is seen in both the physician assessed and the patient reported, right? Remember what we said, it's almost like the drug ad thing, is we can only put the answer that we can prove, and the only one of these answer choices that were decent that we can prove is going to be actually answer choice A. This one says, based on the physician assessment data, the number of patients who need to be treated with saw palmetto to show significant improvement in one patient is which of the following? Well, they're asking number needed to treat, 1 over the absolute risk reduction. But be careful, because it says physician assessment data, and of course that's going to be the second one, right? They want you to jump all over that first one, but the difference between treatment and no treatment, right? Event rate control minus event rate treatment. So anyways, it's going to be 0.63 minus 0.38. Okay, I'm going to take the difference between those guys. Heck, I already did it right there, right, technically. So that's going to be 0.25, which is actually, I always like to think it's 25 over 100. And if I did the inverse of that, okay, whatever your math style is, I get a number 4, right? If I do this, the answer is going to be 4. So the number needed to treat is going to be A, 4. So you really got to like these, this number needed to treat stuff. Very, very popular question. And let me see, we got this one, looks like our last one here. It talks about statistical power in the study. Okay, well, anytime I see this whole power thing, I better go back to my whole null hypothesis box. I do this, and I always put reality on top. I put a test, and then I can kind of start plugging things in. A randomized controlled trial is conducted to assess the effectiveness of a new combination of drug antihypertensive therapy, drug X, compared to the standard antihypertensive single therapy. Study participants include 140 women, 70%, and 60 men ages 30 to 60, with baseline blood pressure 150, 95, or higher. The investigators find antihypertensive therapy is effective. The treatment resulted in a blood pressure measurement below, okay, so 140 over 90. So, okay. When designing the study, the investigators set the probability of wrongly finding that drug X is more effective than standard therapy as 1%. Okay. So that they essentially said, look, we're going to set our p-value, or our alpha error is going to be at 1%, or 0.01, right? The probability of wrongly finding that drug X is more effective than standard therapy. That what they're saying is that in reality there would be no association, but the test said that there would be one. So then they say they set the probability of wrongly finding the effectiveness of two drugs is the same as 10%. So if their test said wrongly that there is no association, but in reality there was one, they're saying that's going to be 0.1. What is the power? Now we know power is this box. Now, so here's the thing on this. They're going to do this to you. They're going to see if you know how to write in this null hypothesis stuff, but you got to know how to fill in the box, and they're going to put it in words for you, okay? But if you just find out, they're going to do this. They're going to say there's an alpha or a p-value, and then they're going to say here's the beta, but they're going to describe beta in words, and then they're just going to most likely either ask you for power, or they'll give you the power and ask for the beta. So in this one, it's going to be the asking for the power, and all we know is we take 1 minus the 0.10, and we're going to get 0.9, and that's going to be 90% answer choice D. Okay, so guys, that's kind of all that I have. You know, I took these questions from the essentially from that USMLE .org web page, and just took all the ones that were BIOSTATS. So they're expecting us to know these things. But again, go through them quick. The more problems that you see, the more that you can work, the better off that will be for the exam. So I hope this helps, and we'll see you in the next video.